Hello everybody, this is the Physical Science Study Guide for Module 2. We're going over the answers for this, and the first thing in number 1 is vocabulary words. So the first one is the substance in a solution that does the dissolving. Let me get this written down here. Okay, if you remember, here's the solution with my chicken leg spoon. Okay, it's pouring it into, we're going to make this water. Okay, the stuff that's being poured in is called a solute. The stuff into which you're pouring is the solvent. This is the stuff that dissolves. And the whole thing together is called the solution. Okay, so the stuff that is doing the dissolving is the solvent. Okay, the next one under there is a homogeneous mixture. Okay, and the solvent, just a second, the solvent is C. A homogeneous mixture made by dissolving one substance in another. One in another. Okay, we already talked about that's what's going on here. The solute is dissolved in the solvent and the whole thing is called a solution. So this is a solution. That's the answer. And a solution is A. And the last one is, no, it's not there yet. All the way down. If you look at the fourth one down, it's the substance in a solution that gets dissolved. Okay, and this is the fourth definition down, and we've already talked about it right here. It's that stuff coming off of my spoon, and it's the solute, and the solute is B. Whoops, B. Okay. Let me get these cleared. So we've got solution, solute, and solvent done. So now we're going to go to the next one. The third one down, the third definition down is the state of matter with a definite volume, but not a definite shape. Well, you've got, if it has no definite shape, it's going to fit into its container and flow around in there. Okay, so that would be a liquid. And a liquid is E. Okay, we've done the fourth definition. So the fifth one is the ratio of a substance's mass to volume. Okay, this is the definition of density. So D equals M over V. Okay, you need to know this formula so that you can do problems with it. And density is G. The next one down is a state of matter. Definite shape. Definite volume. Okay, when you see the state of matter, or it could also be phase of matter, they're talking solid, liquid, or gas. So those are your three choices. If they throw in plasma, they're just trying to make you crazy because plasma's in outer space, so don't worry about it. Okay, so definite shape, gas does not have a definite shape, liquid does not have a definite shape, solid does have a definite shape. So your answer is solid. And just to check, does solid have a definite volume? Yes, it does. And solid is D. Okay, the next one is the movement in gas and liquid that spreads out particles. We did a lab on this. So the answer is, drumroll, diffusion. And diffusion is H. Diffusion is the answer, and it's H. And the last one is the state of matter that has no shape, no volume. Okay, remember, state of matter or phase of matter tells us that it's either solid, liquid, or gas. Now, we've already talked about solid has a definite shape and a definite volume. Liquid has a definite volume, but no definite shape. Gas is the one that has no shape and no volume. Okay, so the answer is F. Okay, now we're going to complete this diagram, which we've done in class. Okay, it starts at the top with matter. This is one way that matter and different substances can be ordered, classified, okay? So the first thing is it a pure substance? If you remember, a pure substance only has one kind of atom in it or one kind of compound in it. And the other one is a mixture. Now, each of these can be divided down further. Okay, so a pure substance can have just one kind of atom, which is an element. And I'm just going to put one atom down here so you can remember. Or it can be a compound, which, if you remember the definition, is 2 plus types of atoms bonded together in a fixed ratio. Now, there's not enough room in your chart to write this whole thing out, but I wanted you to hear it. Okay, compound is the answer they're looking for. Now, in a mixture, there are two different kinds of mixtures. If you remember, there's the heterogeneous, and there's also homogeneous. Okay, heterogeneous is different parts are different. So I'm just going to put different down here. And homogeneous, this prefix means same, means that different parts are the same. Okay, a heterogeneous mixture would be something like this. So we have this little piece, and then we've got lots and lots of these atoms. Then we've got some more of these going on here, and then we've got more X's. Okay, so if I took a sample from here and a sample from here, they would be different. It would be different. Where a homogeneous mixture is like, see how they're all evenly mixed together? So if I took a sample from here, I have one X and I have one O. If I took a sample from here, it's one X and one O. Okay, so that's an example of a homogeneous mixture. And you can also have solutions in there. That's not in your book. You can write it on the second line if you want to, but I just wanted you to see it. Okay, we are on question number 3 now. All matter takes up space and something else. Something else. Okay. Does all matter dissolve in water? Like, no. Because, for example, sand, some rocks, wood doesn't just dissolve in water no matter how much you mix it. So A is not part of your solution. B, has mass. Whoops. Has mass. That means weight. Has an amount of stuff in it. So that one would be good. Let's check through them though. Has shape. Well, does everything have a shape? Well, what about liquids? Liquids don't have a shape. So no, C's not going to be it. And last is visible. Well, what about oxygen? We know it's there because we breathe it, but it is not visible. So D is not an issue. So B is going to be our answer. Matter, all matter takes up space and has mass. Okay, number 4. Which of these substances is not an element? So we're not element. So we need to figure out if these things are elements. And you can pull out your periodic table if you want to. Okay, A is water. Now, if you know the scientific abbreviation for water is H2O. We'll get back to that in a minute. So hydrogen is H2, and that is on our periodic table, and it is number 1. C is aluminum, and its abbreviation is Al. And if you look on the periodic table, it's over in the green section, and it is number 13. So that is an element. And the last one is iron. The abbreviation for iron, believe it or not, is Fe. Fe is right in the middle of the yellow section of your periodic table, and it is number 26. Now on the test, if they ask you if something's an element or not an element, you are perfectly okay to use your periodic table. Bring it out. That's why you've got it. Okay, so B was an element, C was an element, and D was an element, and water is a compound. It's got 2 hydrogens and 1 oxygen, so it is not an element. Okay, all pure substances. All pure substances. Something's true about all pure substances. This is number 5. Now we have to figure out by looking at this. Okay, contain 1 type of atom. I'll put type in here. Well, some pure substances have only 1 atom type, like if you had water or mercury or copper or something like that. But some, not water, that's what I was thinking about. Water is a compound. It has 2 different types of atoms, so this can't be right. Okay, B is can be broken down into simpler substances. Well, H2O could be broken down into simpler substances, could be broken down into hydrogen and oxygen. That really cannot be broken down into simpler substances, certainly describes an element, types of atoms, has a variable composition. Composition means Let me get it written here. Composition means what it's made of. And variable means it can change. And that's part of the definition of a pure substance, is it only has one atom or one compound all the way through it. So it does not have a variable composition. So these two are out. So I hope D is true, or we might be in trouble. Okay, a fixed composition. Now this is very different from C. It's the opposite of it. So this one is what would be true. Okay, 6. 3 phases of matter. Remember what we talked about before? Phases, or also states, you will see come up. Gas, liquid, solid. And that is answer C. Okay, 7. Salty water. Okay, salty water is a mixture. We talked about that in class. Okay, we can make our little solution here. And we've got water, H2O. And then we've got, I'm going to make little dots instead of my silly spoon. Okay, we've got this salt that's gone into it, and that's NaCl. So the solution of salt and water has 2 compounds in it, and they're mixed together, so they're homogeneous. It's a homogeneous solution. Okay, so let's figure out which it was. Salty water is best classified as an element. Does it have one element? No, it has 4 different elements. It has sodium in it, it has chlorine in it, it has hydrogen in it, it has oxygen, so it is not one element. Okay, B is a compound. Well, if you see, there are 2 compounds here. It's not just one compound, so it can't be that. C is a mixture. Well, we know that a solution is a mixture, so that is your answer. And D, look at this, plasma. They just threw that in to mix you up. Plasma is only in outer space. Okay, it's in like suns and stars. It's not in salt water. Nope, it's not. Okay, so let's go on. We are in number 8. We're halfway there. Which of the following is not an example of a physical property? Okay, so you've got physical property where there are no changes in the atom arrangement when you look at them, or you have a chemical property which talks about rearranging atoms. So let's judge this on the basis of this. Okay, so melting point. Now let's think about water. If you have an ice cube, I can draw a cube, so I'm going to draw a cube. Okay, so you have an ice cube and it melts. The ice cube is H2O. And the liquid water is also H2O. There's no change in the atoms. They're still H2O. So this is a physical property. Okay, B is reactivity. This is how much a substance reacts with another substance to form new substances. For example, Fe and O2 combine together to make rust, which is, there's several different kinds of rusts, but we'll have FeO, and then I'll balance this out to make it the right thing. For example, oxygen is very reactive. Okay, so it could be that. If you notice, the iron and the oxygen's atoms have been rearranged to make rust. But we're going to look at the other ones. Density. Density is mass over volume. And that doesn't change the atom structure. It's just a measurement of its mass divided by its volume. So that's not the answer. And D would be hardness. Now the atoms don't need to change to look at hardness. You can squeeze it, you can scratch it. So our answer is B, reactivity. Okay, 9. A property metals have in common is that they A, conduct electricity. Remember, we're talking about metals here. Conduct electricity. Okay. B is they take the shape of their container. Now, most metals are solid. Think about a fork. Okay, is a fork going to take the shape of a container if you put it in a spoon? No, it's a solid. Liquids or gases do that, but not solids. Okay, C, dissolve in water. Now think about that spoon. You put a spoon in water, and no matter how much you stir it, it is not going to dissolve. So that's not going to be true. And then D, can be broken down into other substances. Okay, you'll say can be broken down. Now this might be kind of confusing. Because you have alloys, which are different metals mixed together. But there are many metals that are just elements. There's only one type of atom in them. Copper, aluminum are two examples of this, and they cannot be broken down into anything further. An alloy can be separated out if you know how to do it, but a metal element cannot be broken down. So this cannot be true. So they all conduct electricity. Okay, let's turn the page. 10. What action involves a chemical change? So we're looking for a chemical change. Now, if you remember, chemical change talks about, whoops, let me erase that. Chemical change talks about rearranging atoms. So we need to look at each one of these answers and ask ourselves, are the atoms the same? Or are they getting rearranged? So A is making sweet tea. You add the water, you add the sugar, you make a solution, and it's a mixture, but it's just a mixture. It's not actually rearranging atoms. Okay, B is freezing water. Freezing water. Okay, you've got a big drops of water going into an ice cube. This is H2O. This is H2O. They're just attached to each other differently. Okay, so they're both the same. So freezing water would also be a physical change. C, shredding paper. Okay, paper is a big piece, and paper as little tiny shreds is still paper, and so there is no change in the atoms. So let's hope D is it. Baking a cake. If you remember in the text, it talked about baking a cake. You have several different chemical changes going on, and certainly that batter before you put it into the oven comes out a yummy cake, very different from what went in. Okay, evaporation and condensation. Okay, if you remember, evaporation is a liquid. You add heat to it and it becomes a gas. And condensation is a gas and you take the heat out of it and it becomes a liquid. Okay, so we're changing phases here. So are they chemical changes? Okay, the gas to the liquid. Always think about water with this. If you say Here's a water vapor in the air and it becomes a drop of water. This is H2O, and these little droplets of water are just super tiny and you can't see them, but it's still H2O. So it is not a chemical change because there is no change in the atom. Okay, so we can cross that out. B, they're both liquid to a gas. Oh no, that's not right. Okay, let me erase. Okay, it says in the production of a liquid from a gas. So it's gas to liquid. Well, if you notice, only condensation right here is a gas to a liquid. This is not. So we're going to cross it off. Okay, the next one says involve a change of phase. Well, they do both involve a change of phase. So we're going to keep that in our list for possible answers. And the last one says identical processes. No, they are not identical processes. In evaporation from liquid to gas, you're breaking apart some of those molecules from each other and they're floating off into the air. Gas to a liquid, you're binding some of those particles together and they become heavier and stick together more. So they are not identical processes. So it's a change of phase, C. 12. What is the difference between an element and a compound? Okay, an element is one type of atom. All of the different substances on the periodic table are elements, and we're going to talk about that in the next molecule. A compound, and I'll write out the full definition, but hopefully you remember, compound has two or more kinds of atoms bonded together. That's important. They can't just be mixed up. They have to be bonded together in a fixed ratio. Oops. Or proportion. Sometimes people will write proportion. And that simply means H2O, it always has two hydrogens and one oxygen. If there's no little number down here, it means there's one. Okay, 13. We have to decide if all these things are a physical property or if they are a chemical property. So we have red color. Well, the color is something we see and it doesn't change just by looking at it, so it's physical. Okay, B is flammability. Okay, flammability means how does it burn? And burning cannot stay the same. The atoms change. So this will be chemical because the atoms change in burning. Okay, C is density. Density doesn't change looking at it, so it's physical. Doesn't change the atoms. The atoms stay the same before you do it as in after. Okay, next is solubility. Solubility is simply mixing something into a solution, usually in water, but it can be in other liquids too. Even in the solution, those atoms are still the same. So this is a physical property. E is melting point. If you remember with the ice cube and the water around it, the ice cube was H2O and the melted water was also H2O. So it's just a change in phase, not a change of the actual atoms. So that's physical. Okay, F is odor. Odor doesn't change smelling it, so it is physical. hardness. As you look at something or as you touch it and squeeze it, the hardness doesn't change. So that's going to be a physical property. Okay, H is reacts with water. And this word reacts ought to be enough just to give you a clue, because once it's reacting, it's chemical. You're going to form a new substance. The bubbles also should give you a clue. Okay, and the last one is malleability, which simply means that you can form it and hammer it and push it and in order to make a sheet. The atoms don't change. They don't become something different. So this is a physical property. Okay, in 14, we're going to do very much the same thing, except now we're doing physical change and chemical change. So A, salt dissolves in water. Well, that salt dissolving in water, the atoms are still the same. Okay, you have water, you have salt, it disappears, but the sodium's still in there and the chlorine's still in there, so it's still salt in there. So that is a physical change. No, yeah, physical change. Okay, B, penny is cut in two. Anything you cut into 2 pieces or 10 pieces or 100 pieces is still got the same atoms and molecules and compounds all the same as it was before. So this is physical. Okay, C, acid and base react. To form a salt, water, and heat. Okay, here's the key word, react. And then you got new things over here. So the acid and bases molecular structure is now changed into salt, water, and heat. So this is chemical. Okay, D, water is heated and turned to steam. So you had liquid water became steam, which is also water. So this is a physical change. There was no change in the atoms. Okay, E, copper reacts with moist air to form a patina. Okay, again, you have that key word reacts, and it forms something different which is a patina, which is that green color. So this is a chemical change. Something new was formed. The atoms were rearranged. Okay, F, iron rusts. This is very much the same as E. We talked about it before. And I'll write out the chemical formulas. So you have 2Fe plus O2 yields 2FeO. You notice the iron and the oxygen. This is a sign that means reacts together and the combination is different. They were by themselves over here, and then here they're together. So this is a chemical change. Okay, ice melts. Again, this is a phase change. If you think of the ice cube and the water, draw this again. Okay, the ice cube is made of H2O and the puddle is made of H2O. There's no change in the atomic structure. So it's physical. Okay, H, milk curdles. Milk curdling is a chemical change. You had a solid appear in a liquid that didn't have a solid in it before. So that is a chemical change. And I, the volume of air decreases when the temperature increases. Okay, basically this is just a movement of molecules closer together or further apart with a change in temperature. There's no change in the molecules. They didn't react. They didn't form anything new. So it is a physical change. Okay, 15. Would breaking down a compound into its elements be a physical or a chemical change, and why? Well, let's look at H2O. We're going to break H2O down into its elements, which are hydrogen and oxygen. So we need 2 of these, and we need 2 of these. Okay. So this is a chemical reaction for this. This is what you start with, which is water, and this is what you end with, which is hydrogen and oxygen. Now we can look at this, and these two substances are bonded together, and water, which is liquid and flows around, is pretty different from hydrogen gas and oxygen gas, which are both kind of reactive and explosive. So it's formed 2 different substances. It's broken down into 2 different substances. So this is a chemical change. And it's a chemical change because the arrangements of the atoms have changed. I'll put atomic arrangement changes. Or you could say new substances are formed. Any of those, either one of those would be fine. Okay, our last one. Viscosity. Why is viscosity classified as a physical property? Okay, viscosity is simply, whoops. Okay, I'm going to fix that. Viscosity is simply the ability of a liquid to flow. Some liquids are thick, some liquids are thin, or, it all is different. So why is it a physical property? Okay, if you have a drop of molasses here, and 10 minutes later it flows down, and there's a drip and a drop of molasses down here, there's no change in molasses. This is molasses, and this is molasses. There's no change in the atoms. It's the same substance. And that's why it's classified as a physical property, because there's no change in atoms. It doesn't affect the structure of the molasses. Okay, that is the end of the study guide. Make sure before you take the test that you review rust. Okay, that's important. And we'll see you later. Thank you. Bye-bye.